The difference quotient of a function is very commonly seen in applications, specifically in calculus. The definition of the difference quotient of a function f at an x value, x equals a, is f of a plus h minus f of a over h. And you may recognize this as a net change in the numerator. It's f of a plus h minus f of a. And when we divide by h, that is dividing by the change in the x value, because the x value changes from a to a plus h. Okay. What this is doing, let me draw a picture. If you have a function, okay, and we're going from a, and then we have some distance, and we're going to call this a plus h. That means that this distance right here is h. Okay. F of a plus h is this y value up here. Okay, that's f of a plus h. And f of a is this y value right there, f of a. And of course, the x values of these points are a and a plus h. So if I were to draw a line connecting these 2 points, it would look like about that. Okay, oh, I kind of missed that point. But we'd get this line going through those 2 points. And the slope of this line would actually be the change in y over the change in x. Well, the change in y is f of a plus h minus f of a. And the change in x is just h. So this difference quotient is the slope of the line connecting those 2 points. Let's do this example. Let f of x equal 2x squared plus 3x minus 1. Find the difference quotient of f at x equals a. So we are going to need f of a plus h, because we're going to be plugging it into that spot right there. I'm not going to worry about this whole expression quite yet. I'm just going to go ahead and plug in the a plus h and see what I get. So that means I plug a plus h into each of these x's. 2 times a plus h squared plus 3 times a plus h minus 1. Now I can expand this. Okay, so my a plus h squared, that expands to a squared plus 2ah plus h squared, and then plus the 3 times a plus h minus the 1. And now we're going to distribute the 2 into those parentheses and the 3 into these parentheses. So that gives us 2a squared plus 4ah plus 2h squared, and then plus 3a plus 3h, and minus 1. Next, we need to plug that into this expression here. So f of a plus h minus f of a over h. F of a plus h is this expression that I just got. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. That's f of a plus h minus now f of a. Now f of a is just plugging a into the x values here. So that is, and I'm going to put this all in parentheses because I'm subtracting the whole thing, 2a squared plus 3a minus 1. And then that is divided by h. Now, I can distribute this negative into those parentheses, and then I'll be able to see that there's a lot of things here that are going to cancel out of the numerator. And that should always be the case, generally be the case when you are doing the difference quotient. So I have minus 2a squared minus 3a plus 1. And that is all over h. Now I can find the things that cancel. Notice that I have a 2a squared and a minus 2a squared, so those are gone. And I have a plus 3a and a minus 3a, so those are gone. And I have a minus 1 and a plus 1, and those are gone. So after canceling all of those things out, I just have terms here that have an h in them. And we're going to factor the h out. So I factor h out, and I have a 4a plus 2h. Notice I pulled an h out of the h squared, so it's just h. And then plus 3, and I pulled the h out, so it's just the 3 there. And that's divided by h. Okay, and now that I have an h as a factor, I can cancel that out. Now you have to be very careful, because when you cancel something out, that is assuming that it's not equal to 0. So I end up with the 4a plus 2h plus 3, but it's only actually equal if h is not equal to 0, because you're not allowed to cancel out 0. Okay, now if h was equal to 0, of course the original difference quotient would not have been defined. So this is the difference quotient of the function 2x squared plus 3x minus 1 at x equals a.